Alright guys, welcome to our video about solving two-step equations. So last time you guys learned how to solve equations that have one step. So now we're going to talk about what we do if there's two steps to solving an equation. Alright, so it's still the same as last time where x is some unknown variable that's being multiplied by 3 and then 8 is being subtracted and we have to get 7. So if we refer back to our last video, we might think, oh, we have to divide by 3, right? Because we have 3 times x. But we also have this minus 8. So we have to figure out, well, how do I know what step to do first? So if we think about x all by itself, so we start with x. If we pretend nothing else is in our equation except x, okay? And then something happens to x. The first thing that happens to x is it's being multiplied by 3. So I'm just going to make a list off to the side of all the things that are happening to x. Okay, so we have times 3. And then we subtract 8. So when we are undoing, we are going to do these steps right here, but backwards. So we're going to start with the minus 8, and we're going to undo this by adding 8. So we're going to add 8 to both sides. And so this makes our 0, and so we can cross that out, and so we're left with 3 times x equals 15. So now we're at the one-step part. So we come to the next one on our list, and we multiplied by 3, so we're going to divide both sides by 3. So we have x equals 5. So the key when you're solving a two-step equation is figure out the order of what happened to x if x started all by itself, and then do those steps backwards. So if you have some sort of subtraction or addition, you're going to have to do that first before you can undo the multiplication or the division.
All right, let's check out another example. Let's tell the story of x kind of off to the side over here, just like Emma showed us earlier. So we got x. What is happening with x? All right, x, we look at parentheses first if you remember our order of operations. And so within the parentheses, x is being subtracted by 4. So we got minus 4, and then all of that is being multiplied. Again, if they're just touching each other, that's implied multiplication. It's all being multiplied by 1/6. Okay, and we're just going to take our steps and go backwards. So our first one is being multiplied by 1/6. The opposite or undoing multiplication is division. So I can divide by 1/6 on both sides. Or we can do what we showed you in the last video, where 1 divided by 6 is the same as multiplying by 6 on top. So I'm going to use the reciprocal method. So 6 over 1. And again, 1 over 1 is just 1, and 6 over 6 is just 1. So that's how that side gets undone. So I'm multiplying by 6 over 1 here. And I got to do the same thing over here. Multiply by 6 over 1 here. And I'm left with x minus 4 equals... And again, 3 is the same as 3 over 1, if that helps you out. So 3 times 6 is 18. 18 over 1 is the same as 18, so I can just leave it as that. All right, next up is to undo the minus 4. To undo subtraction, I use addition, so I'm going to add 4 to both sides. And I'm left with x equals 18 plus 4 is 22, I believe. And I can always check my answer if I plug it back in. So if I want to check myself, I could do 1/6 times 22 minus 4. Does that equal 3? All right, 22 minus 4 is 18. 18 times a 6, or 18 divided by 6, is equal to 3 indeed. So that does work out.
All right, guys, so now we are going to look at another example, and this one is going to have a couple fractions in it. Okay. So we're going to start by telling the story of x. So if we have x by itself, okay, and then the first thing that happens to x is it's being multiplied by 1/7. And then after it's multiplied by 1/7, 4 is being added. Okay, so now we know the order of our steps, so we're going to work backwards. So if we have plus 4, we are going to minus 4 because subtraction and addition undo each other. So plus 4 and minus 4 gives us our 0, which is what we want. So we are left with 1/7 x on this side equals 5/7 minus 4. You're welcome to plug this into your calculator, or you can do it by hand by finding common denominators. So if we have 5/7 minus 4, to make 4 have a common denominator of 7, we have to multiply it. So if we multiply it by 7, then we have 4 over 1 times 7 over 7 is going to give us 7 on the bottom, and then 28 on the top. So we'll have 5 minus 28 equals negative 23 over 7. And again, if you want to plug that into your calculator, feel free. And if you do have fractions in your final answer in your derivative assignments, just enter them in a fraction. You don't have to worry about turning it into a decimal. All right, sweet. So we've done that step. Now we are on our times 1/7 step. So from multiplying by 1/7, we're going to do the opposite, which is divide by 1/7, or multiply by the reciprocal, which is 7 over 1. And so this whole piece of this part of our equation becomes 1. So we're left with x equals, and then we have to multiply this side by 7 over 1 as well. 7 divided by 7 is 1, and we're just left with negative 23 over 1, which is just negative 23. So this is our final answer.
All right, what if we have an example where we got 2x, like x on both sides? All right, the story of x might be a little bit more confusing here because I have 2 things going on with x. So my first step always, if I have a variable on both sides, is to try to bring one to the other side. So that's always our first step, is to move our x's onto the same side. On your derivative assignment, it could be x, it could be y, it could be a different variable, but whatever it might be, you want to bring them together. Because there's just x, like 5x over here, I think I would rather bring the 2x over here than I have x on one side and a constant on the other side. You can bring the 5x over here, but then you just made it an extra step. So I'm going to move the 2x to undo a positive 2x. I'm going to minus 2x. And what I would do this side, I got to do over here to keep our equation balanced. This is a 0 pair, and now we're left with 3 equals 5x minus 2x. Some students think that the x's go away, but think of it like 5 apples, and I take away 2 apples, so now I'm left with 3 apples. Like I still have that variable there. I still have x pieces I'm working with. So now I got 3 equals 3x, and now I can tell the story of x. So what's happening with x? X is being multiplied by 3. So multiplied by 3. So working backwards, to undo times 3, I look here and I know opposite of multiplication is division. So I'm going to divide by 3, and that makes a 1, which is perfect. And I got to do it to this side as well. So now I got 1 times x equals 3 over 3 is the same thing as 1, or x equals 1. And again, you can plug it back in. If you're going to plug it back in, you have to plug it into anywhere it says x. So I would do 2 times 1 plus 3 equals 5 times 1 as well. So I have to replace x in both spots. And that's what 2 plus 3, and that does indeed equal 5. 5 equals 5, so that does check out.